You probably know laser light from dance clubs, laser shows, movies, or games. But what exactly is laser light? And what makes lasers so different from any other light source? You might know from laser pointers that laser light has one color and that all the light goes in a narrow beam in the same direction. However, by sending the light of this bulb through a color filter and a small hole, we also get a narrow beam of one color, similar to the laser beam. But it is much less powerful. So, what is the difference? To understand this, we need to look a bit closer to see how light is generated. Actually, we have to look very close, down to the atomic level. If we switch on the light bulb, the electric current heats up the metal wire, adding energy to the atoms. Atoms can release excess energy by emitting a small portion of energy as electromagnetic wave, a so-called photon. The energy of a photon depends solely on its frequency. Glowing metal generates all kinds of photons in different directions and at different frequencies. There are other methods to make light, which can generate photons with specific frequencies. One of them is probably used by the lamps in the ceiling above you, the so-called gas discharge. It is a very effective way of generating light and used in many types of lamps, and even in plasma TVs. In a gas discharge lamp, free electrons are accelerated in an electric field. When they crash into one of the gas atoms, they can kick out electrons, leaving a positively charged ion. If this free place is filled again by an electron, energy is freed and emitted as a photon. In a fluorescent light tube, the generated photons have a frequency which is too high to be visible for our eyes. Therefore, a phosphor powder on the inside of the tube transforms these high-energy photons into photons with lower energy and visible frequencies. Even after the transformation to visible photons, the light of a light tube consists of only 4 or 5 different frequencies. Yet, like in a light bulb, these photons go in arbitrary directions. In laser light, on the other hand, the photons are not just similar, they are identical. They do not only go in the same direction and have the same frequency, but they also oscillate synchronously. Scientists would say they are coherent. But how can we make such coherent light? Although the first laser was only built in 1960, Einstein already predicted in 1917 how it should be possible to produce such identical photons. Atoms can be in an excited state if one of its electrons is at a high energy level, for example after absorbing a high energy photon, while a lower energy level is free. Einstein understood that if such an atom would be hit by a photon of the same energy as the photon that the atom was about to send out, the incident photon is effectively copied. If most of the atoms are at a high energy level, this process repeats many times until thousands of identical photons leave the laser material. This effect is called stimulated emission and is the reason why the laser is called laser. Laser stands for light amplification by stimulated emission of radiation. To make the laser light even stronger, scientists came up with the idea to place 2 mirrors around the laser material. These mirrors are aligned such that in one particular direction, the photons are reflected back and forth between them. At each pass through the laser material, more identical photons are generated. Soon, every atom that absorbs a high-energy photon is shortly after hit by one of the photons bouncing between the mirrors. Thus, in the laser, the light gets stronger and stronger. But how do we get the laser beam out of the laser? The trick is to make one of the mirrors a little bit transparent, so that just a few % of the laser light can pass. Depending on the strength of the laser, these few % can be enough to cut through metal. Laser light can be an extremely powerful tool and is used in lots of applications, like today's communication technology and many entertainment products. It is also used in extremely precise surgery. Scientists even make lasers to measure the distance to the moon or control microscopic objects in the nano world. Nobody today can say how smart minds will use lasers in the future. What seems science fiction today might be a common technology tomorrow. Now that you know a bit more about the power of laser light, what would you like to do with it?